день, дорогие друзья.
Hello, friends.
Меня зовут Роман Тихонов.
My name is
Я
Roman
возглавляю
Tikhonov.
управление модельным риском в группе
I'm
SberDS.
head of
Сегодня мы с вами
risk
поговорим
models
немножко о другой
at
теме.
SberBank.
И речь наша пойдет о том, как
Today we'll
управлять
talk about
моделями машинного обучения
management of ML models at the SberDS platform. You can't do it through traditional means.
Об этом я вам расскажу, как именно мы справляемся.
So I'll tell you what we do at SberBank.
Мы разработали свою внутреннюю платформу.
So we have an in-house platform, SberDS, that helps us to stay competitive and grow our business. So let's look at this model, why it's so important. You know that SberBank is a big organization, and you have a lot of models here at SberBank. And as part of this conference, my colleague will give you more about risk modeling. We won't focus on it too much, but just trust us. We at SberBank use thousands of models and you need to manage them. We can't just ask one person and say what is happening with all of these models. We need to have a corporate system that would enable us to understand the status of each model, what statuses there are, and most importantly, understand what kind of model it is, what is happening to those models, whether they are implemented, deployed or not. There are standards in our industry, and RiskDM is one of the standards. These are life cycle standards of any model. Any model has its own life cycle. You can break it down into several stages. First of all is data preparation. You can't create a model without data. Second is the training the model, then validation, whether it complies with minimum requirements, some kind of quality assurance. If it's fine, then you have execution or implementation, and once it's introduced, we need to make sure that it operates in line with requirements. This is why we need to have such continuous practice as monitoring. To operationalize the management of the life cycle of this number of models, we use such a tool as the library of models. Why? It helps us to store data about the model, about all the artifacts that we can see during the design and for the validation. It's the storage of all the knowledge and data. It helps to operationalize the life cycle of the model. Why is it so important? As I said, we have standards, we have stages, there are many more models that we have, not just one. And one person cannot cover all of that. These are complicated tasks. Again, we are a huge organization. You need a concerted effort to maximize efficiency at each stage. You need a different set of competencies. Data mining and data processing involves different stages. Validation is similar to data scientists, but it's a different function. It's very important not to have any conflict of interest between data scientists and validation. And the deployment of the models is also a specific task. It's not the data scientists that do it, it's more engineers, IT engineers. So these are different professions, different sets of skills. Second, responsibility is key. We have a large number of models that we want to introduce. There could be different difficulties at every stage, and that would stand in the way of the implementation. We need to have ownership, someone who is accountable. It's much easier to fix issues, much easier to monitor and manage the entire process. And the library of models enables us to see everything and to personalize it. You have specific roles assigned to data scientists, engineers, validators. The implementation team is in charge of deployment. And you also have one dedicated person who's in charge of the entire model, who will be in charge of its flaws and also will be able to fix its issues. And throughout this life cycle, you have many intermediary stages. When you move data, when you move the model between different stages, validation report, etc. It's important to store everything, to enrich at every stage, so that when it's finally over, when the model is deployed, you have everything documented, you keep all the artifacts, you can roll it back, you can look back, and you can introduce changes into existing model because you have the entire log for it. If it's under the surveillance by the central bank, you can always get it validated by the regulator and make sure that it's in full compliance with all the requirements. So the library of the models is the cornerstone, is the foundation. Let's look at specific stages of the cycle. I don't want to talk a lot about data preparation. It's more of a traditional job. At the level of big companies, it's now a dedicated function. Data engineers are in charge of it. There is a lot of exciting stuff that we can tell you, but it's not part of my report today. So let's look at training and designing a model. You know how the traditional design process looks like, but I would like to talk about the industrial application. Suppose I'm a data scientist and I want to design a new model. What do I need? Data, some kind of task, well, because I need to model some process, and then I get into an integrated coding system and I start coding. So you come up with one model, and then I pass it over for validation. You can do it like this, and that's one of the processes that we use. But what's particular about what we do at Sberbank? Well, if it's a major organization, not a startup, then I'm sure you have to work with complicated models, some computational tasks, and you might end up in a situation when one coding environment is not enough. You need, for example, to train the model or components of a model on several coding environments, when you need several terabytes, when you need several computers. This is why this platform allows you to do that. So you can decompose different tasks into different paths. Second, you might want to code some of the elements,
Каскада моделей.
different elements of your program in different languages, Python, Spark,
На Аре, на Spark.
you name it,
Ну почему? Ну,
due to different
по разным
reasons.
причинам, да. Во-первых, потому что
These languages have different libraries,
библиотеки, и
and
библиотеки.
these libraries are not always identical to each other.
Во-вторых, какие-то возможности
And
есть.
there are advantages of one environment, of one language, and they might be missing in another language. And so blending is very effective, and our platform enables us to do this. You can merge all of these languages as part of one model. You can rely on different languages with different computational units. So
Допустим, вы разработали модель.
finally, you have the model,
Теперь вы
and you now want to
попробовать какой-то
try a
новый
new
модель.
library.
Ну,
Maybe someone has done better than you.
вот. И здесь,
And it's really great
очень удобно
to have an opportunity
возможность, да,
to take this
просто
library
взять эту библиотеку, да,
and not to initiate it from GitHub or whatever,
да, не разбираться
not to
в
get into
документации,
its
в
documentation,
параметрах,
but just click an icon
в вашем проекте, да,
in your project
и в
and
этом кубике просто
just
через элементы
go through this
такие,
cube
да,
and through some
простые
simple
параметры,
interface
и
elements
получить какую-то
get a
альтернативную
very
версию,
simple
да,
version
сравнить её с разработанной
and
моделью.
visualize it and compare with what you have to do the
Это
benchmarking.
позволяет, да, в
And in
реальном
certain
случае,
cases, it helps you to improve the quality of your own model, or to use an interact, or to use an alternative model. As for the visual interface, data scientists do the code.
всем понятно, да?
As you know, a model is a code.
И это здорово,
That's
да,
great.
это прекрасно
But
Но
imagine you're a part of a big organization and you have thousands of models,
моделей, не знаю, там, куча
huge
задач,
number of assignments
3 года вперед.
planned out
Какие-то
for
модели дорабатываются,
3 years ahead.
должен вы ее сделать,
So
ну,
you
кто-то её должен
code one model and someone needs to streamline it or repurpose
Это,
it.
ну,
It's a
в
not
общем,
trivial
нетривиальная
task.
задача, если ваша модель сохранена просто как plain-text, просто как код. Потому что другой
If
человек должен
your
это
model
разобрать.
is stored as some kind of code, because another person would have to dig into it and figure out how it was done. So it's really great if we can decompose the development of a code into certain components, and it could be visualized as some kind of interface elements. Why it's good? Because it's easy to repurpose that. If you store the project in this way, you can see some visual graphs and you see the status, you can see the stages. Again, it can be done in one cluster or several clusters, in one language or several languages, in one library or several libraries. And if you can visualize it, you can repurpose it, you can hand it over to another team so that they can do their own model. In this case, the efficiency of coding is much higher. And finally, the visual constructor is a critical component here. You take your model or a code that is part of the model, and you can wrap it in some graphic visual interface and represent it as a cube, as a kind of a visual interface, and hand it over to your colleagues. If you're a great data scientist who can do some unique stuff, you don't do it just for a one-off occasion. Your experienced colleagues can later on use some of the code from your model for their own purposes, so it has boosted our efficiency enormously. Moving on. So we have this model, we need to validate it. We can't just take its word and say, yes, it's successful. Yeah, we cannot just use a raw model, a rough model in a scoring process where 500,000 applications for loans are being processed. So we need to validate it, make sure this is the right model. We have independent validation. In this case, it's like quality assurance. It needs to comply with some minimum requirements. And again, it's an attempt to assess whether this model could be improved and whether we can get extra economic benefit. So we might say, this is a good mod, but we can fine-tune it and the economic yield would be higher by certain percentage points. So how does it look in real life? Data scientist comes up with a model, they document it, you keep it as part of the library, you have the artifacts. Once it's over, it says, hand it over for validation. We have the automated workflow, and then the validator opens it, does analysis. It could be qualitative, quantitative analysis. They run a lot of tests, they simulate it. The validation report is sent, validation is over, they press one button, data scientist gets the report. Well, if it's unsatisfactory, what happens next? The data scientist takes this report, reads the report. If he doesn't have any questions, he just says, okay, he starts revising. If he does have questions, he comes to the validator and says, hey, I don't like it, I disagree with it, and they consult. And okay, we have revised the model, the validation kicks in, everything's fine, it's been approved. But it could still, is it possible that even in the second iteration it's not satisfactory? Yes, we could have up to 5 iterations. It might be a very challenging job. It could be an inexperienced coder. We might have newcomers, you know, young boys, fresh out from university. They want to start with very ambitious tasks, but sometimes it's much easier to start with simple things, or the data could be processed in a wrong way. So there could be a host of situations why the models are not validated at one go. So it's a multi-iteration process, it's reliable, but it takes a lot of time. If we are to test a lot of product hypotheses very fast, if we want to do it in a quality manner, we need a different approach. And we've come up with a different approach based on our platform. What does it look like? It doesn't apply to all the models, but a large number of them does go through this new pipeline. Here's how it looks like. Instead of doing that many iterations, we take the data scientist, we look at the product people, we get into subject matter, and we figure out which models could be validated in an automated way. So we can code a program, take a lot of tests, put them, package them into one project, generate an automated report. So you can replicate the validator's process in terms of the financial assessment, etc. You can package it into one project. Not just packaging it into one project, but you can combine it into one simple cube for the data scientist, with a clear entrance and a clear exit. Clear entrance, it means the data and the model, and exit, it means the outcome of the validation process. We have the green or the red, and you have the report, which tells you how you get green or the red light. So the data scientist designs the model in SberDS, and then they add the validation cube. It runs this. The model goes through this validation process, and they get either the green or the red light. If it's the green light, then they just press the button, introduce the model, deploy it, roll out. So rolling out is a headache. It could be even more painful than the data preparation. So rolling out is extremely difficult. Execution is very important, but you first need to roll it out. So what do we do? And how does it look like traditionally at many organizations? So we can do a model based on some data. It could be picked from different sources over a long period of time. So we code it in a certain environment. It could be a local working station, it could be server, it doesn't matter really. So it could be based on some framework or with Python, for example. So we want to roll it out. And we understand that there are many systems, each with their own syntax, each having their own data, and it's not the data that were initially used. I mean, we designed this model in a lab environment, but we will roll it out and use in the industrial environment. So there are several issues. How do we decode it from the design language into the execution language? How do we make sure that the structure of the data is identical, the classes and the model and the types of the data are the same? And the third, how do we ensure that there is proper execution? It's either a package execution or online or on demand. You click a button, the model is run, and you get the results. So there is a host of tasks, and sometimes it takes up to 1 month to fix it. So it takes a lot of effort, and there could be a lot of mistakes. Decoding, recoding models could be very difficult. Syntax is difficult, and syntax could be so inconvenient. It's not just 2 strings of code in Python. No. It could be really bulky, it could be low-level code, and 1 error, plus or minus, could immediately lead to billions worth of losses. So you need verification control. So it's time consuming, and it's also consuming in terms of human resources, in terms of skills. So what do we offer? Okay, we have a model in one platform. So we do it on a broad window of data. So we roll it out on an industrial scale, and that helps us to resolve the integration issue. Integration is already done, it's inherent. And second, we don't use any recoding, because the model, the way it's designed, it's the same way it's implemented. I showed you, it's in the previous slides. This is the execution code. The design code is the execution code. You just click one button to publish. That's it. And you just need to choose the system that you want to be published in. That's it. The model has been designed, it's been validated. Once it's published, we can fine-tune monitoring. You can set up monitoring. So what is monitoring? Monitoring is the same as validation, but for a model that's already being run, that's already executed. Monitoring is extremely important. Thanks to it, we can identify the model risks at an early stage and take timely action to mitigate this risk. What kind of measures? Recoding, replacement, switching off, using another model. There are a host of options. I don't want to talk about it. My colleagues will talk about it in their reports. But this monitoring allows us to do it on a timely fashion, this auto monitoring could be run any second. If something changes in this model, depends on the model dynamic. So we can do it without the participation of a human. If we have thousands of models, we won't be able to find the necessary amount of people to verify the quality. So it needs to be done in an automated way, in a very fast way, and very often. And you have to do it for the models that are in that industrial execution mode. The traditional validation process has its own peculiarities. Sometimes it's really difficult to verify a model that is currently implemented industrially. The design, validation and rollout of a model as part of the platform gives you 100% guarantee that the code of the model will not be changed once the model is designed, validated and executed. In terms of the structure, nothing will happen to the model up until the moment when we need to revise it. You can use retraining. If you start retraining, then revalidation is also automatically launched. What are the benefits? The upside is that we can identify threats at an early stage, very fast. What kind of threats? We need to be able to prevent threats when we design it and when we roll it out. Second, our models use some kind of flow information related to the behavior of the customers. So, unlike the previous case when macroeconomics plays a key role, here you have consumer behavior that is important. Data scientists know that models have an expiry date. A model is just an approximation of the real process. So there is some kind of entropy that is embedded in the model. You cannot have a model that would run forever. Everything changes, so we need to keep track of these changes. One of the goals we had and for this auto-monitoring project was to enable those who are in charge of the process to have this indicator in front of their eyes so that they could see what's happening with the models. The data scientist says goodbye to the model, that's it. The validator does their job, that's it. And then this model is in professional mode. We know that validation helps to do the auto monitoring, but it's the owner of the model that has to keep track of it. They have to keep the model on their radar, and that definitely improves the efficiency and monetizes, helps to improve the monetization of this model. That's it from me. Thank you so much for your attention. I hope I didn't get you bored. I'd be happy to take your questions.